So this studio is the design and research studio of Blended Living, and it's led by Barry Wack and Levan Osra. I hope I'm pronouncing the names right. And and they're unit masters of Bartlett B Pro, and well, just let you do your self-introduction.
Yeah, that's that's fine. Thanks. Thanks so much for the introduction. What I'm going to do is just share my screen very quickly. Okay. Are you guys with me on screen?
Yeah.
Yeah, I can see it.
So firstly, thanks so much for joining us today, everyone. My name's Barry Wark, and I'm a lecturer at the Bartlett. I teach on the undergraduate course there, and I also teach on the B Pro course with my colleague Levant Osra. I think I would say that our combined research interests are in new procedural computation methodologies, but also how that relates to what we might describe as nature in architecture or ecology in architecture. So I'm just going to quickly go through some of these images to explain a bit the process that we might undertake in the studio. So we'll be developing what we call models. So really trying to use Houdini to develop small little tests. And then we'll probably then expand these tests out into what we normally call chunks. So they become architectural spaces. And then from there, we'll develop these projects out into something much more architectural and much more urban. We've got lots of experience. We understand computation, we understand fabrication, we make lots of prototypes. And this is actually some images from a studio that I just completed in America. So you can see that if you work very, very hard, that as tutors, we can take you guys as far as you want to go. Now, we're not promising that this is the kind of work that you will have, but what we're promising is that this is the kind of work you could get to if you apply yourselves within the studio. So in a way, our attitude is that we will always give you the opportunity to go as far as you can and be as good as you can. And we're going to help you in every single stage of that. But what we like to do is we like to open the highway for you to really take control of your own project. The main tool that we'll be using within this methodology is Houdini. Houdini is a relatively new software in architectural design, but it's already finding its impact not only in academia, but in the built environment as well. We're now starting to see this stuff being fabricated and designed in practice using Houdini. So my colleague Levant, who I'll be running the studio with, is going to just do a very short demonstration of a couple of things in the interface to give you guys a taste of what it's like to work in Houdini. In terms of the schedule and these kind of things, I hope you guys will just look at the handout that we've made. And if you have any questions, we'd be more than happy to take those questions from you. So Levant, if you are ready.
Sorry, I'm just trying to. How do you share screen?
Up on the top right, next to leave, there's a box with an arrow pointing up.
Okay. Let's see. Okay. Yes, there we go. Does everyone see it?
Yeah, you're good to go.
Do you see this weird thing or no?
No, we only see the Houdini interface.
Okay. So, sorry, just a second. Basically, I will be using Houdini, and which is a procedural design software. And what it does is it allows you to do descriptions for design rather than free modeling. So that means whatever decision you do or whatever design you do, you can make it as scripts like this. It's a bit like Grasshopper, but more advanced. And let's say you can come here, click on one of them. So this is one of the methodologies we're going to work, where we're going to blend organic geometry to angular or orthogonal. But this is just one design iteration. However, if we go back in the script, let's say here, we can change stuff. So we can change its form. We can then come there. We can change like the scale of the orthogonal language, or make it very small, like that. We can also do many other things, such as, sorry, controlling like how this blend occurs, etc. So it can be fully organic, fully angular, or somewhere in between. So to cut short, we're like very interested in iterations and differentiation, and not just like working on one thing, but testing different results and versions from this procedural scripting. And even when you think of just a box, essentially this is a box, but then you add a node, and suddenly the box is distorted, right? And then you can get like another node. Then you can start to kind of extrude this box. You can say it's going to be individual elements. Then you can decide, and you don't want this like distortion, so you can turn it off, and you can come back here. So make it like that. So now it's like pyramids, for example. But then if you use a subdivide node, then the geometry would change. I can get a smooth node like that to make it more pointy. I can also work with a lot of copied objects. Like I can get a box, then I can say I want some points in this box. So now there's 1,000 points. I can make it 200. Then I can copy other boxes, which are kind of huge now, but if I make them smaller, so now I have a composition with a lot of boxes. Then I can say, well, these boxes are the same size, so why don't I make them like different to get some porosity? Yes. And then I can say, well, actually, they're like very angular. I want them more fluid. So I can convert them to voxels, which are like pixels, and we're going to dive into these topics in very much detail. And then I can just make it more fluid, close the gaps. So now those boxes are creating something more fluid and connected. Yeah.
So I think the important thing to say here is that this, we would argue that this is the most powerful design tool around right now. that's why we want to use it with you guys in the studio. So we really see this as the kind of the future of design tools and architecture. And Levant and I are, again, arguably world leaders in using this software and architecture. And we've been really excited to explore this with you in the studio. So I think with that, we can probably take some questions from you guys, if there is any. Please, anything, like there's no such thing as a silly question. You can ask us whatever you want. Okay, maybe everyone's just mesmerized by Houdini then.
Is this something that you could export it straight to 3D print?
Yes.
Yes.
It creates the cleanest meshes out of any software I know.
Yeah, I think a lot of software needs cleaning up the meshes before 3D print.
Yeah.
And
I mean, I've literally sent something like 10 separate files to 3D print, and it's only taken me a couple of minutes to do that, like no cleaning.
oh, nice.
I am actually helping someone to make their files 3D printable because they have very messy files in Rhino. And basically I take them to Houdini and then it takes 5 minutes to fix them. So Houdini is like extremely powerful for 3D printing because if you work in Houdini, it usually always gives you closed meshes, like almost always. And if you don't work in Houdini, there are many ways to kind of use Houdini to fix it.
And what do you see the potential or the extent it could go when I apply this to architecture? So when creating spaces, is there a limit or there's just no limit?
I mean, there's definitely no limits because I think for me, if we think about the early digital project in architecture, what happens is you 3D model for like a couple of days, then you go to your client and your client says, oh, make it smaller, make it bigger, I don't like this.
Yeah.
And rather than have to then spend 3 days, 4 days modeling everything again, I literally just change like 2 numbers and then it's fixed.
Sounds amazing.
Right? So what we're doing is we're using the power of computation to reduce our manual labor in architecture and give us more time to think about the conceptual framework in which we produce that architecture, which I would argue is the role of architects. So that's how I would answer that question. There's no limits.
Definitely.
One
like,
question.
Yeah,
Question. Is there a live Boolean tool in this software?
Yes.
That you can,
yes.
and compared to say Maya or kind of
Maya cannot compete.
what's the biggest advantage you think this software is?
It works with voxels, so you can determine the resolution, whereas mesh-based modeling, it's a very kind of not stupid, but it's like an unnecessary way of calculating a Boolean operation because essentially you're always obsessed with kind of the mesh form. Whereas when you work with voxels, imagine it's like Photoshop. So in Photoshop, you can have a white canvas and you can paint it with black. But the second you want to delete something, essentially it just picks and chooses those voxels or pixels and changes the value to white again. So it's like a very simple way of, it's either yes or no kind of thing.
But these are exactly the kind of topics that we will go over in the studio. And this is exactly the kind of research, the computational research that Levant and I have been doing over the last, well, for me, to sort of like quite slightly longer, but, these are exactly the kind of topics that we'll explore in the studio. So if you've got specific questions or things that you want to like do, then we can explore that.
See a lot of.
You don't have to show it just now, Levant. Like, we'll do it in the studio, yeah?
Yeah.
Is that powerful when you come to sculpting?
It's not a sculpting software. If you want to be a sculptor, then use ZBrush. this is being defined by relationships, and how you change those relationships change what's produced. But I would argue that both Levant and I have very sculptural architecture, and we don't need to use ZBrush. So if that's something you're interested in, then that's something you can certainly do in the studio.
Mm-hmm. Nice.
Yeah, great. Is there any more questions from the crowd?
I got a quick question actually. When it comes to software like this, basically Maya, Houdini, Cinema 4D, ZBrush, all that, you create models that usually are not like you won't the measurement and scale won't be the priority thing you think of when you create sculpture like this. I mean, like models like this. What is the workflow that how you transition from these kind of abstract sculpture or abstract models into something that you can work on as an architecture or architects, then makes things into, like, for example, in scale measurement to be right and all that?
Yeah, I mean, I think just from our side, like, you're basically asking one of the fundamental questions of computational architecture right now. And if we create a kind of duality and we say, okay, let's talk about this parametricism versus like components. So, you know, if we make that simple duality, there's the kind of model that says you make this stuff, you don't care, and then you figure out how to make it later on. This is like what we call top down. So you make a shape, then you figure it out, okay? The other way is to say that you have a bottom up approach. So basically the components make the architecture. It's a kind of more modernist idea, yeah, but it's now a kind of like what people call the discrete. For us in the studio, for us in particular, what we're trying to help you guys with is actually not to do those things, because you can go into a practice or you can buy a book off the internet that will teach you how to make the constructions, yeah? What we're trying to do, particularly in our studio, is to help you develop your conceptual framework through which you can design. Because what I really believe is that there's a lot of people out there who've got great ideas and great visions for architecture, but they cannot model or materialize them in the world. So you can't model what you can imagine. And what we're trying to argue for, Levant and I, is that through Houdini, you can imagine and reimagine that project much quicker and develop the conceptual framework around it. So our studio is not necessarily going to be attacking notions of construction, but maybe there's others that are. But if you want to be the guy in your office that does all the design work, and everyone comes to you because they want the cool concept or the cool vision for the project, then, you know, you should be in our studio.
Yeah, so you guys are pushing the boundary of even design sketches won't be able to, like, if you can't visualize something, maybe you can't sketch it out, or maybe you can doodle it out, but then this is more like a doodling tool, is it?
For us, like sketching, it's more 3D. It's less about
3D doodle.
It's less about doing a sketch on paper and putting it in the background in Rhino and drafting it over. And it's more like, how can we learn to be intuitive with a software that is extremely rule-based? And that very notion, I think we are at a very good position worldwide, because this is a mainly visual effects tool, but we know how to use it as architectural as it could get without killing the magic.
Great.
Okay, probably take too much time. Sorry. Great, thank you so much, guys.
Thanks so much.
Thank you so much, Barry and Levant.